Hello and welcome to Live Lab number 16 on how to build, train and tune a machine learning model, a state-of-the-art machine learning model in this time Amazon SageMaker Canvas. You already learned how to build and train a machine learning model in EC2. You also learned how to build and train a machine learning model in SageMaker Studio Classic. You also learned how to build and train and tune and even build an automated machine learning pipeline in AWS Lambda. And now finally, the last tool that is missing is Amazon SageMaker Canvas, and that's exactly what you're going to learn today. We will build and train and tune a state-of-the-art machine learning model in Amazon SageMaker Canvas. All right, so here we go. Let's start. I'm going to share my screen, entire screen, share, and here we go. So let's go to the console home in AWS. This is my new Data Science in the Cloud account. By the way, I'm going to go into the North Virginia region. Perfect. And the beautiful thing about Amazon SageMaker Canvas is that actually we don't have to upload the datasets to S3. Indeed, that's one of the rare services where you don't have to upload the dataset into S3, because you'll see that you will directly be able to upload it from your local machine to Canvas. Okay, so here we go. Let's go to Amazon SageMaker. In the search bar, you enter SageMaker. Okay, Amazon SageMaker. And our first step will be to create a domain. So let's wait for it to load. There you go. Amazon SageMaker, build, train, and deploy machine learning models at scale. All right, so the first step here, the very first step is to click this button, set up for single user, because that's how you can create a domain. As you can see here, a domain is compulsory for whatever you want to do within SageMaker. Okay, so now it is preparing the SageMaker domain. All right, so now it is preparing the SageMaker domain. It's going to take 2 or 3 minutes, and very soon you should have your domain ready. All right, the domain is ready. It is in service. So now the next step will be to create a user. So inside your domain, you're going to click Add User here, and there we go. This is your user. So let's call it by your name. I'm going to call it Hadlin. Okay. Then it will automatically create an Amazon SageMaker execution role, which will be important because some artifacts will be created into an S3 bucket, which will be automatically created as well. So we just need this Amazon SageMaker execution role so that SageMaker can access S3. All right, but mostly in terms of writing into S3. Okay, so then we're going to click Next. Here, this is not important. We can click Next. Same, not important. This is RStudio. We won't use it. You can click Next. And here, this is where you can configure the Canvas storage. So as I told you, when we're going to create the data sets and the models, some artifacts will be created into S3. And so this is where you can configure this. So let's keep system managed. This is fine. Or you can, choose a custom S3 bucket. But let's keep that so that the S3 bucket will be automatically created and we don't have to worry about S3. Okay. So this is good. Canvas ready to use models configuration. This is good as well. Create a new execution role. Yes, that's going to be the execution role in IAM. Perfect. We can scroll down. Time series forecasting configuration. We could disable it because we won't use time series forecasting, but it's okay. You can keep this. This won't change anything. And MLOps configuration. Yes, Canvas is very good for MLOps. So if you want, you can keep this. And now let's click submit. All right, so we quickly saw that the role was successfully created and now the user profile is successfully created. Perfect. So this is your user profile. And now to finally use Amazon SageMaker Canvas, you just need to click Launch here. And then be careful, you're not going to click Studio. You actually learn how to build and train and tune a machine learning model in Amazon SageMaker Studio Classic in the Data Science in the Cloud course. But this time in this lab, we're going to use Canvas. We're going to learn how to do it in Canvas. And if you took that Data Science in the Cloud course and you watched those SageMaker Studio lectures, well, you will see that actually Amazon SageMaker Canvas is much easier to use than Studio Classic. You will see the interface is actually a bit more user-friendly, and you don't even have to upload the data from S3. You can directly upload it from your machine, and then you can easily enter a new, single prediction, which you can't do in Amazon SageMaker Studio Classic, right? Because you can only do batch predictions or real-time predictions. So there you go. Yeah, I think you will love Canvas. You will see it's very user-friendly and very nice to use. All right, so let's wait for it to load. And very soon we will be entering SageMaker Canvas. Excellent, and welcome to Amazon SageMaker Canvas. As I told you, it's a very user-friendly platform. So let's have a look. Here, this is the home page where you can build a custom model, compare GenAI models and query docs, explore ready-to-use models. This is basically get started shortcuts. Here on the left, that's what is interesting. So here, this is where you can do some data wrangler. Let's have a look at what you can do specifically here. You will see you can create data flows. Yes. So here, this is where you can create a data flow indeed, where you start by importing the data, then you prepare the data, you pre-process the data, then you scale data operations, and then finally you build models. Okay, but we won't use this in this lab. Then here, this is where you can create data sets. Okay, here, this is where you can create your models, your machine learning models. Following this flow, you start by selecting the data set, then you build the model, you analyze the model, you make some predictions, and then you deploy the model, in the form of an endpoint, so that you can use your machine learning model from outside Canvas. Then here, this is where you can do ML ops, ML operations. Okay, so this is new actually. Amazon SageMaker Canvas supports comprehensive data preparation, including a conversational interface for data transformation, GenAI capabilities to access, evaluate, and fine-tune LLMs, configuration of parameters to build models, and the ability to directly deploy models to real-time endpoints. Very good. Here, this is where you can use some ready-to-use AI solutions, okay, like document queries, sentiment analysis, language detection, entities extraction, personal information detection, object detection in images, expense analysis, text detection in images, identify document analysis, document analysis. So these are basically ready-to-use AI solutions. Here, this is where you can do some Gen AI, like fine-tuning some LLMs, like the Llama 2 7B chat. You can fine-tune this one, okay, so that you can augment the knowledge with very specific knowledge. It is a technique that we call knowledge augmentation. Okay, but this is not the topic of this lab. Here, this is the help, documentation, hands-on exercises, good, and community forum. Okay, good. All right, so now let's start what we want to do, which is to build two machine learning models, one for regression, one for classification. And the first thing we're going to do is upload our data sets, the two data sets that you have in your folder, the zip folder that is attached to the event. Actually, you will find it here. That's the zip folder containing the two data sets, one for regression and one for classification. All right, so let's do that. We're going to click here, import data. Then we're going to click tabular. Here we're going to enter regression, and then we're going to click create. Okay, then here we click select files from your computer. Then there you go. You go to where you downloaded the Datasets.zip folder. After unzipping it, you're going to the datasets folder, and you're going to select this one, regression data CSV file. Okay, open, and I will explain in a second what this dataset is about. It's very simple. It's a classic regression dataset. And now let's click preview datasets so that we can have a look at the dataset. So this is a dataset containing different features: the ambient temperature, the exhaust vacuum, the ambient pressure, and the relative humidity. So these are the features, and you have to predict the net hourly electrical energy output of combined cycle power plant. Okay, so this is the dataset, and as you can see, this is a typical regression dataset because the target that you have to predict here, the net hourly electrical energy output, contains numerical values. Okay, continuous numerical values, real values, and not categories or classes. Okay, so now let's click create dataset, and done. Okay, good. So now that the data is imported for regression, we're going to go to My Models here to start this process, okay? Where the first step is to indeed select the dataset that we just imported in datasets here. So let's do this. Let's click Create New Model. Here, we're going to call it regression model, okay? And we're going to click Create. Yes, here this is for predictive analysis, not for image analysis, text analysis, or fine-tuned foundation model. No, we're really going to do some predictions, make some predictions. So we have to select here predictive analysis. Then we click Create. Okay, and now this is where we select the dataset that we just imported in datasets here. So you select this one, of course, regression, and then you click select dataset. And then now you will see it's so easy. Basically, you just have to select the column that we want to predict, which is of course PE, the last column, the net hourly electrical energy output of the combined cycle power plant. Here in target column, you therefore select PE. Okay, that's our target. Then model type, yes, it's numeric prediction. Okay, for the PE, your model predicts numeric values. Yes, because we are doing regression. Okay. Then all the other features are automatically selected, okay, to predict the target, the net hourly electrical energy output. And now the only thing you have to do, well, first let's click the little arrow here just so that I can show you that you have the choice between quick build or standard build, where standard build is where accuracy is chosen over speed, meaning it will train the model with the highest accuracy by minimizing, of course, overfitting. But unfortunately, this option will take between 2 to 4 hours to find that best model. And then you have quick build, where you choose speed over accuracy, because indeed building usually takes 2 to 15 minutes. Okay, so we're going to choose this one for the purpose of this lab, quick build, and the only thing you have to do is just click quick build. Okay, validating your data. Data validation in progress. Feel free to navigate away. This won't interrupt the process. All right, and here we go with the next step. Analyze. So now we're gonna have the model overview. Our model is now being created. Quick build usually takes 2 to 15 minutes. You can now leave this view. Okay. So you will see, it will be interesting because we will see our first performance metrics, which will be the RMSE, mostly root mean squared error, right? The most relevant performance metric for regression. So let's just wait for the model to be built, trained, and very soon we will see the final results with the performance metrics, RMSE, root mean squared error, and also probably the MSE and others like the mean absolute error. Let's see what we'll get. It will be interesting to see. All right, done. How difficult or easy was it to build a model in Canvas? Very easy, of course. Share feedback. Okay. Thank you. Okay, so the final RMSE is 2.943, which is very good because look at the scale of our values. You know, if we go to the data sets here, and if I open the regression data, well, that's the scale of our target values. So 463, 444, 448, 446, 473. So indeed, 2.943 is a pretty good RMSE. It's a pretty small error, right? And the MSE is 8.659, but that's because it's the mean squared error, mean squared without the root, okay? So the model often predicts a value that is within plus or minus 2.943 of the actual value for PE. So that is indeed very good. You can even find the features impact, okay, with the ambient temperature having the largest impact on the dependent variable that we want to predict, 60%. Then the exhaust vacuum, 26.6%, the ambient pressure, 7%, and the relative humidity, 5.9%. Okay, so that's very interesting. And here you have the graph of the impact of the ambient temperature on the prediction of PE. So here that's the impact on prediction, and here that's the ambient temperature. Okay. Now, if we look into scoring, what do we see? Well, we see this very interesting graph with the actual values of PE with respect to the predicted values of PE. So basically, this line here is where the predictions are equal to the actual values, okay? A hypothetical line. And we see that the points here are close to this line, which means indeed that the predictions are close to the actual values, okay? So this is pretty good. And indeed, the model often predicts a value that is within plus or minus 2.943 of the actual value for PE, which is why the data points here are really close to that ideal prediction line. Okay, and you also have some advanced metrics here with the other regression performance metrics. As I told you, the mean absolute error, the R squared, of course. By the way, it's a really good R squared, 97.018%, really good. Then you also have the MAPE, which is the mean absolute percent error, and the RMSE, okay? Here you have the residuals, okay, which are the actual values minus the predicted values with respect to the predicted values of PE. And here you have the error density. Okay, so pretty good dashboard, right? I really like it, actually. So let's go back to overview with the impact of the different features on the dependent variable, the target, which is the net hourly electrical energy output. And so now let's move on to the next step of this process, this machine learning pipeline, which will be to make some predictions. So let's click predict here. And now what I love about this is that we have two options for predictions. Either we can make batch predictions, we can predict the net hourly electrical energy outputs of several data points in a batch, and we can also make a single prediction. So let's start with batch prediction. I'll show you how to do it. Here we're going to click manual, okay, because we're going to manually add this batch of inputs. So here we're going to click plus create dataset. Here we're going to enter regression batch predictions, okay. Here we're going to click create. Here we're going to click select files from your computer. And this time you're going to enter this one, new data points, which is the batch of new inputs for the regression case study. So new data points.csv, you click open, and then yes, you can preview the data set. So indeed, it's a batch of 3 data points, okay, which contains only, of course, the features of these data points and not the target, because that's what we want to predict, These are new data points, so we want to predict the net hourly electrical energy output for these new data points. Therefore, we don't have the last column here of the target, okay? Here, we're going to create the data set, so we click create data set, okay, and here it is processing now, and now ready, okay. So let's select it, and let's click generate predictions, and very easily, it will predict the net hourly electrical energy output of the 3 data points in our batch of inputs. All right, done. Okay, so I'm going to hide this, okay. Let's click view now to have a look at the predictions, and here they are. All right, so these are our data points, and these are the predictions, okay, and they seem to be very relevant predictions. Okay, for the first data point, it predicted the net hourly electrical energy output of 468. The second one, it predicted 446, and the third one, it predicted 485. Perfect. Okay, you can even download them if you want on your machine, but I will choose not to do it. Okay, and now let me show you how to do a single prediction. Okay, so yes, basically you very simply have to enter your input values here. So let's, for example, enter, I don't know, 27 here. Then here, let's enter 42. Then here, let's enter 1015. I'm just entering random input values, huh? And here, let's enter 101. Okay, just taking random values. Okay, yes, and then we click update prediction, and what will be the prediction? 443. So with these input values I just entered, the predicted net hourly electrical energy output is 443.819. Okay, and that's our new prediction. Perfect. Okay, so it's super easy. And then finally, the last step is to deploy the model so that you can have an endpoint of your model which you can use, which will allow you to use your machine learning model outside of Canvas. All right, that's exactly what will happen if you click create deployment here. As you can see, you can deploy your model to a SageMaker endpoint so that you can make predictions from outside of the Canvas application, test and monitor your model to proactively detect issues such as model drift. Okay, and then you click deploy here. But we won't do it because we are doing this lab within Canvas. We don't need to use our machine learning model outside of Canvas. All right, so that's it for the regression case study. So now we're gonna go back to our models. This is our regression model, which we successfully built and trained and probably tuned a bit, even if we chose that quick build option. And now let's move on to the next case study, which is classification, where this time we will build a classification model for a data set where the target is actually classes, as opposed to numeric values. This time it's going to be classes or, categories. Okay, so first let's import the data set here. So we're going to click import data, then tabular, because it's going to be a CSV file as well. This time we're going to call it classification. We click create. Here we click select files from your computer, then classification data CSV, open. It is importing the data and done. We can preview the dataset just so that I explain to you what the dataset is about. So basically, this is a dataset of patients in several hospitals where each row is a patient, okay? And for each patient, we have different features: the sample code number, the clump thickness, the uniformity of cell size, the uniformity of cell shape, marginal adhesion, single epithelial cell size, and we can't see the other one. So I'm going to show you actually here. Here we're going to click File, Open. All right. Okay. Classification data, open, and there it is. So yeah, where did we stop? Uniformity of cell size, uniformity of cell shape, marginal adhesion, single epithelial cell size, bare nuclei, bland chromatin, normal nuclei, mitosis, and class. So all these features here, you know, all the columns here except the last one are actually features of a breast cancer tumor. Okay, these are features of the breast basically. And the class here, the target, will say if the breast cancer tumor is benign or malignant. If it's benign, it's going to be a 2, and if it's malignant, it's going to be a 4. Okay, so that's exactly what the dataset tells us. Okay, so let's go back to Canvas, and now let's click Create Dataset. Okay, good. Now we have our datasets. So now we can go back to My Models here, and we're going to create a new model, which will be, of course, the classification model. Okay, so we're going to call it classification model. And here we're going to click create because, of course, again, it's going to be predictive analysis that we're going to do. We're going to make predictions for a classification case study based on a dataset that contains classes. Okay, not image analysis, not text analysis, and not fine-tune foundation model. So we can click create. Very good. Here is the classification dataset. So now you can select it and click select dataset. And exactly the same as before, we have to select first a column to predict. So here the target column is, of course, going to be this one, class. Okay. Model type, it's going to be a binary classification. Yes, 2-category prediction. Your model classifies class into 2 categories, 2 for benign cancer tumor or 4 for malignant cancer tumor. Okay, here you have automatically all the features that are selected. Okay, all the ones except class, the target. And now, finally, same as before, the only thing you have to do is to choose 2 options here for your model, either standard build, which will choose accuracy over speed, and which will give you the best classification model with the highest accuracy and without having too much overfitting, you know, by minimizing overfitting, or quick build, which chooses speed over accuracy, and this will take, as before, 2 to 15 minutes, and it's probably going to be actually in the lower bound of this range because the dataset is not that big. Okay, so let's choose quick build again, and here we go. Let's click quick build. Okay, data validation in progress. Feel free to navigate away. This won't interrupt the process, and soon enough we will be taken here to analyze where we will see the accuracy of our classification model, because indeed in classification the relevant performance metric is accuracy. So now the model is being created, it is being trained and tuned probably a little bit. And once it is, well, we will see the final accuracy. And let's hope we have a good one. You know, the higher it is, the better. Let's hope it's going to be around 96%. I think, you know, because in the Data Science in the Cloud course, in the SageMaker section, we actually work on the same data sets, you know, both for regression and classification. And actually, the accuracy that we obtained on the classification dataset was about 97%. So I'm not saying we're going to beat that because we chose the quick build option, but let's see if we get better than 97% accuracy. And if we get 95 or 96, it's still very good. It is still very good. Okay, so let's just wait for the model to be created, and I'll see you in a couple of minutes. All right, and we end up with a 93.431% accuracy. So this is really good. This definitely doesn't beat the accuracy we got in SageMaker Studio Classic, but this is still a very good one. And again, we see the different impacts of the different features, with bare nuclei being the feature that has the most impact on the dependent variable, the class, the target that we want to predict. Then it's uniformity of cell size, uniformity of cell shape, clump thickness, marginal adhesion, bland chromatin, sample code number, strangely, normal nuclei, mitosis, and single epithelial cell size. Okay. Then if we look at the scoring, well, we see the predictions with respect to the actuals. Okay, so basically these are the predictions and these are the actual values, and you get basically the confusion matrix here. Okay, so you have 89 correct predictions of the benign tumor, then you get 48 correct predictions of the malignant tumor. And then the model accuracy insights. If the model predicts 2, it is correct 95.455% of the time. And for the values that are 2 in the dataset, the model predicted 94.382% of them to be 2. Okay? Okay, interesting. And now what about the advanced metrics with the other performance metrics for classification, such as F1? We got a good F1 score of 90.7%. That great accuracy of 93.431%, which is still very good, right? But of course, if you want to try to beat the accuracy we obtained in the data science in the cloud course, you would need to choose the standard build option. Then a precision of 89.7%, a recall of 91.6%, and an area under curve, ROC curve, of 0.973. Okay, there you go. That's the confusion matrix I was looking for. So we have 44 true positives, 84 true negatives, 5 false positive, and 4 false negative. Okay. And then, so here, yeah, metrics table. This is where you got all your performance metrics, such as a precision, recall, accuracy, F1 score, and AUC. This is where you get the confusion matrix, and this is where you get the precision recall curve, okay, with precision in the y-axis and recall in the x-axis, but I can't scroll down here for some reason. No. Okay. Okay, that's all right. So now let's go back to overview and let's move on to the next step of that process, the predict step. So here, let's click predict. And again, you can do batch predictions or a single prediction. So let's start with batch prediction. I prepared a batch of new inputs for you, of new patients with new feature values, but not the targets of the class. So let's click manual here. Okay. Here, let's click create dataset. Here, let's enter classification batch predictions. Classification batch predictions. Let's click create. Select files from your computer. New patients. So that's the data set of new inputs, new patients with new feature values containing 3 new patients, as you can see, not well here. Let's click open. All right, validate in schema and preview data set. Yes, we can have a look. There you go. So these are 3 new patients with 3 new sample code numbers, 3 new clump thickness, 3 new uniformity of cell size, etc. And of course, in this data set, this time I can scroll to the right. Okay, good. Of course, in this data set, there is not the class column because that's what we want to predict. We don't know yet what are the classes. Okay, so let's click create data set and processing. Should be ready in a second now. Ready, perfect. So now let's select it and let's click generate predictions to make the predictions of the breast cancer tumor, whether it is malignant or benign, for these 3 new patients in our new dataset. And there we go. It's ready. We can click view here. And these are the predictions. Not only you have the predictions, but also you have the probability of the class being the prediction. Okay, so let's see. Here, for the first patient in our new dataset of new patients, well, the model predicts 2, meaning that the breast cancer tumor is benign, with a probability of 85% actually, okay? Then for the second patient here, with those new feature values of the breast, well, the model predicts that the breast cancer tumor is unfortunately malignant with 75.8% probability. And finally, for the third patient here, well, for these new feature values, the model predicts that the breast cancer tumor is benign again, with 85% probability. Okay, I like how they give the predictions with the probabilities, which is something we didn't have in SageMaker Studio Classic. And again, you can download them if you need them on your machine, but I don't need them, so I'm just going to close this. And now let's do a single prediction. Okay, yes. with these values, for example, we can change the clump thickness to 2, maybe, uniformity of cell size to 3, marginal adhesion, let's keep 1. Here, let's put, I don't know, 2, okay? So yes, these are feature values. And now you click Update Prediction to update the class of the breast cancer tumor of this particular patient. This is a patient, you know, this corresponds to a new patient where you entered manually the values of the features of that patient, the features of the breast of that patient. Okay, and for this hypothetical patient, well, the model predicts that the breast cancer tumor is benign. It predicts 2. Okay, so good. Actually, it predicts 2 with 83.685% probability. Okay, great, amazing. And again, you can download prediction if you want. And finally, you can deploy the model exactly like before. You click plus create deployment so that you can use your model, you know, your trained model, thanks to an endpoint. It's actually the endpoint that is being created so that you can use this model outside of Canvas. All right, deploy your model to a SageMaker endpoint so that you can make predictions from outside of the Canvas application, test and monitor your model to proactively detect issues such as model drift. Okay, and here you click deployed, but we won't do it. We don't need to use our trained model outside Canvas. Okay, so that brings us to the end of the experiment in Canvas, but please stay here because now we have to do the cleanup. It's extremely important. I don't want you to get charged. So the first thing we're going to do is in My Models here, where you will find your 2 models, regression model and classification model. Very simply, we're going to scroll down. We're going to click those 3 little dots here, and we're going to click delete. We click delete and we click again delete. And this deletes the regression model. Now we're going to do the same for the classification model. We click the 3 little dots, we click delete, and we click delete again. Okay, so that's the first thing to do. Now, in datasets, let's select all of them, classification, batch predictions, classification, regression, batch predictions, and regression. And let's click here, delete. All right, deleted. And these were previous datasets that were here by default, so no need to delete them. Okay, and now we're going to click logout. Logout, because we deleted everything we had to delete in Canvas. Good. Now you can close this. This is fine. And now, even if we did not create any S3 bucket, well, you will see that an S3 bucket, some S3 buckets were actually automatically created, and so we have to delete them as well. So here in the search bar, I'm going to enter S3, and I'm going to open S3 in a new tab because you will see that we'll still have some things to delete in SageMaker here, okay? But let's start with S3. Okay, there you go. As I was telling you, some buckets were automatically created as we were performing our SageMaker experiment. So let's just delete them one by one. Here, this one is empty, so you can directly delete it. Okay, so for this, you just enter the name of the bucket. You paste it here, and you delete the bucket. All right, successfully deleted. Now this one, same, we can delete it directly because it is empty. So we click delete here. We enter the name of the bucket. We paste it here. We delete the bucket. Okay, and finally the third one, well, it is not empty, so we can't delete it directly. We have to empty it first. So actually, I can show you what's inside. You have some Canvas folders. So let's go back to the bucket. Let's select it. Let's empty it first. And here you just enter, well, I'm going to copy it. You just have to enter permanently delete. You paste it, you click empty. Okay, empty the bucket, successfully empty the bucket. You click exit, you select it, you click delete, and now there you go. You just have to enter the name of the bucket, copy, paste, and then delete bucket. All right, perfect. We're done with S3. We can close S3. Actually, if you want to do a full cleanup, we're also going to delete the roles in IAM that were automatically created. So let's try that. Let's go to the roles. Okay, good. And you see all these roles that were created? So we're just going to select all the roles here except the ones that we hear by default: AWS service role for trusted advisor, AWS service role for support, and AWS service role for service quotas. Okay, all the rest you can delete them. So let's click delete. Let's enter delete here, and let's click delete. All right, and it's going to delete all the SageMaker roles. Okay, while it's deleting the roles, now let's go to SageMaker. Let's go back to SageMaker. And of course, here what we have to delete is the domain. It's very important that you do this. You have to delete the domain. So how to delete the domain? Well, first you have to delete the user profile, okay? But you can't delete the user profile directly. Before, you have to delete the apps in the user profile. And to do so, you click space management here, okay? And there you go, you have to delete this first. So you select it, you will find some space here, okay? You select it, you click delete, yes, delete space, you enter delete here and you click delete space. Space canvas was successfully deleted, great. So now you go back to the user profile, you enter your user profile. The app is deleted already, that's what we just did. So now you're going to scroll down, click edit here at the bottom right, and you're going to click delete user. Yes, yes, delete user, you enter delete here and you click delete. Adlan is pending deletion. Please wait until the profile is removed from the user table. Perfect. So now let's go back to the roles. They failed to delete one role. This is completely normal. Actually, if you want to delete this one, you also have to wait for everything to be deleted and even a bit of time after that. So I probably won't be able to show it to you in this lab, but yes, come back to your console in IAM sometime later after the deletion of everything, after the cleanup, and you will be able to delete this one. This is AWS Service Role for Amazon SageMaker Notebooks. If you want, I'll try again. After we delete everything we have to delete in SageMaker, but I think it will even not be possible to delete it after. Okay, Adlan is pending deletion. Actually, sometimes in AWS, this can continue forever, so you just have to refresh, and let's see if it is already deleted. Yes, it is deleted. Perfect. So the user is deleted. Now we still have to delete the domain. So let's go back to the domains and let's delete this domain. Quick setup domain. You select it. You click edit. Okay, good. And here you click delete domain. Yes, delete my domain. You enter delete here and you click delete. And your domain is pending deletion and this may take a few minutes. So again, let's wait 1 or 2 minutes and then let's refresh to see if it's already deleted. And then we'll be almost done. The only thing we'll have to do left is to remove a few things in the training tab on the left-hand panel here. So I'll show you. Your domain is pending deletion and this may take a few minutes. Actually, let's try to refresh already to see if it's already deleted. And deleted, no domain, perfect. So cleanup done here. And now the final thing we have to do is just check these 3 sections here, processing, training, and inference. Let's start with processing. Let's check the processing jobs. No resources, perfect. Now training, algorithms, all good here. Training jobs. Yeah, there you go. You have 2 training jobs. So you can select them, click actions, and well, you see, you don't even have to delete them. They're all good. They will disappear at some point, but it is fine. This won't incur any charge. Okay, same for this one. Actions, clone, create, add edit tags. Okay, so we're all good here. Hyperparameter tuning jobs, all good. Inference, compilation jobs, all is good. I'm just doing some checks. It's important to always check that you don't have anything in SageMaker. Endpoint configurations, all good. Endpoints, all good. Batch transform jobs, all good. Shadow tests, all good. Inference recommended, all good. So you see, you have more things to delete here when you use SageMaker Studio Classic, but here we use Canvas, so we had nothing to delete. So it all is good. Basically, for Amazon SageMaker Canvas, you only have to delete your domain. And to delete your domain, remember, you start with the space, you delete the space first, then you delete the user profile, and then you delete the domain. Okay, so that brings us to the end of this lab. Congratulations for having completed it up to the end. I was super glad to give this new lab to you. Now you know how to build and train and tune a model in every AWS resource. So congratulations for that. I'm just going to try again to delete that role. If we see it's going to work, I'm just going to enter this, paste it here, delete. Let's see if it works this time so that we can do a full cleanup. But as I told you, it's probably going to take a bit more time to be able to delete that role, even after doing the full and complete cleanup on SageMaker. Deleting role. Let's remove that red thing so that we don't confuse anything. Deleting role. Role deleted. There you go. So now the full cleanup is done. Congratulations. Not only you successfully completed the lab, but also you are completely risk-free of getting charged. All right. So thank you so much again for attending. I'll see you in the next live lab. And until then, enjoy the cloud.